Hello viewers, in this video we are going to learn about Relational Algebra Query Language in DBMS. Relational Algebra, it is also known as Procedural Query Language because in this, queries describes a clear roadmap or else a step-by-step procedure for computing the desired answer. Because in this, queries are expressed using a collection of operators. That's why they clearly describes a step-by-step procedure for computing the desired answer. So these queries are useful for designing databases, particularly for representing optimized query execution plans. Okay. Coming to the fundamental property of relational algebra, every operator in relational algebra takes one or more relation as its input, and after performing the database operation, they produces only one relation as its output. Okay. This relational algebra query language provides a theoretical foundation for querying and manipulating data. That's why the persons who would like to be a database designer, database administrator, and those who would like to work more on the conceptual level of the DBMS, and for the computer science students, having the clear knowledge on relational algebra will be very much important. Here, I would like to highlight one of the important points about relational algebra. Students, whenever the queries are received by the DBMS, they are in the format SQL, right? So, when these SQL commands are received by DBMS, what it does for performing any database operation, it converts those SQL into relational algebra. Why these commands are received translated into relational algebra? Because then only the DBMS can make an optimized query execution plan. So with help of optimized query execution plan, it quickly can retrieve the data or manipulate the data, and all the database operations can be performed in the optimized manner. So, to achieve any database operation in an optimized manner, if the queries are composed of using operators instead of English-like statements as in SQL, so it would be better. That's why SQL commands are converted into relational algebra form in DBMS. That's why having a knowledge on relational algebra is much required for the computer science students. Now discuss the various operators which are supported in relational algebra. The operators which are supported in relational algebra can be categorized into two types. One is basic operators and another one is additional or extended or derived operators. Okay. These basic operators are useful for performing fundamental operations, whereas coming to the additional operators, these operators are the combinations of multiple basic operators or extensions of basic operators and are useful for performing complex operations. These additional operators are useful for performing complex operations. But these complex operations can also be performed only with the help of multiple basic operators, and without additional operators also these complex operations can be performed. That's why these operators are also known as extended operators or derived operators. Okay. You can notice here in both the category basic as well as additional operators, the operators can again be classified into unary and binary based on the number of input tables they take. Okay, coming to the unary operators, they always take only one input table, and after performing the database operations, they produces only one output table. Similarly, coming to the binary operators, they always take two input tables, and after performing the operations, they produces only one output table. Okay. Let us now discuss what are the operators are available under unary operator of basic operators. Here selection and projection operators are available under unary operators because they take only one input tables. Coming to the binary operators of basic operators, union, cross product, set difference operators are classified under this because they take two input tables and produces one output table. Similarly, under the additional operator, unary operator of additional operator, rename is included because it takes only one input table and produces one output table. And similarly, coming to the binary operators of additional operator, intersection, division, join operators are classified under this because they work on two input tables and produces only one output table. In this lecture, we are going to discuss the basic operators along with suitable examples. In this lecture, all the examples are explained using the Saylor's relation and reserves relations. Okay, coming to the Saylor relation, it takes four fields. Their names are SID, SName, rating, and age, and its domains are integer, string, integer, and real. Coming to the reserves relation, it takes three fields SID, BID, day, and their domains are integer, integer, and date. Okay, and particularly based on these relations, it's S1 instance and S2 instance of sailors and R1 instance of reserves are taken. What is in by instance of a relation? Instance of a relation is a table that follows the schema defined by the relation and includes the data which are present at a particular point in time. Okay, that's why for a relation there can be any number of instances be available. Okay, let us now discuss the selection operator in relational algebra. Selection operator, it selects the subset of rows. Selection operator, it selects the subset of rows that satisfy the selection condition. Okay, coming to its syntax, here selection operator, what is selection operator? Sigma is the selection operator, right? So sigma need to be first specified and as its subscript, the selection condition need to be specified and within parentheses, the input relation need to be specified. Here, since selection operator is a unary operator, it always takes only one input table. Okay, let us now discuss what is the form of specifying the selection condition. Selection condition can be specified by using any comparison operator and in its left side it takes attributes and in its right side it may take any constant or else attribute also can be present. Okay, let us now discuss selection operator with an example query. Here, the query taken for explaining the selection operator is retrieve rows from S2 instance of sailors in which rating above 8. Okay. Here, what is the input table? S2 instance of sailors is the input table. Okay. What is the condition? Rating must be greater than 8. This is the condition. So, for specifying the selection query, we need input table and condition. So, by applying the sigma operator, we can formulate the query. Here, this is the input table, that is S2 instance of sailors, and now the query can be specified. This is the selection operator and the condition is rating greater than 8 and the input table is S2 instance of sailors relation. Okay, now when this selection operator sigma is applied on this input table, it selects the subset of rows in which the rating values are greater than 9. Okay, so these two rows will be selected and produced in the output relation. Okay, students, here you can notice the schema of the output relation is not modified when the sigma operator is applied. Okay, let us now discuss the projection operator. Projection operator, it projects only a certain set of attributes of a relation. Attributes also known as columns or fields, right? So, projection operator, it projects or selects only the certain columns of a relation. Okay, coming to the syntax for specifying the projection operation, pi operator is used, followed by that in it as its subscript the set of attributes which need to be present in the output and input table also must be specified within parentheses. Here projection operator is the unary operator, right? So it takes only one input table. Okay, here whenever projection operator is applied in the resultant table, it always contains the distinct tuples, and it will not contain any of the duplicate tuples. It eliminates the duplication in the output table. Okay. Let us formulate a query based on the projection operator in order to find all sailors' name and ratings present in the S2 instance of sailor. Okay. Here, what are the attribute list must be present in the output table? Sailors' names and ratings. What is the input table? S2 instance of sailors. S2 instance of sailors. So, input table and attribute list is available. Now we can apply the projection operator. Okay, so using the projection operator inside the attribute list, S name and rating are specified, and the S2 instance input table is specified within parentheses. When this query is applied on this input table, and it projects only the columns which are having the names S name and the rating. So it projects only these two columns and produces in the output table. Okay, let us now discuss the operator composition. Okay, it is very common combining the selection and projection operation in order to perform additional operations or complex operations in relations. Okay, for example, in order to compute the names and ratings of highly rated sailors in S2 instance of sailors, S2 instance of sailors, highly rated sailor means who are having the rating value greater than 8. Okay, so here what is the input table? S2 instance of the sailor table is the input table, and in that, what is the condition to be satisfied? Their rating value must be greater than 8. And what are the field names must be available in the output table? Names and ratings. Okay, so with all these available inputs, let us formulate a query by using both the projection as well as selection operators. Okay, here input table is S2, right? Here, whenever we combine selection as well as projection, the selection operator must be applied first, and after that only projection operator need to be specified. That's why whenever we formulate the query, the selection operator must be included within the parenthesis. So meaning of this is that whatever the operation or expression is specified within parenthesis, that used to be evaluated first, right? So accordingly, the selection operator need to be executed first. That's why they need to be present inside the parenthesis only. Okay, so let us apply the selection operator and specify the condition. What is the condition? The rating value must be greater than 8. And what is the input table? S2 instance of sailor is the input table. Okay, so first this query will be evaluated and it will produce the intermediate table. After that, the selection operator and its attribute values will be also applied. Okay, so when this query is applied, first this part of the query will be executed. Then it will produce an intermediate relation like this. Here you can notice the intermediate relation. Since selection operator is applied, it selects the subset of rows in which the rating values are greater than 8. Okay, so now this is the intermediate relation. On this input table, now this projection operator will be applied. Okay, so this is the input table. Okay, in this projection operator will be applied. When it is applied, it will project only the columns which are having S name and a rating, and produces in the output table. This is how whenever the selection and projection operators are combined, first selection operator is executed first, followed by that pi operator will be executed. Coming to the set operations in relational algebra, set operators are the binary operators, right? So they work on two tables and produce a single table as the output. Okay, so what is the condition for the input table? That is very important whenever we learn about set operations. Okay, whenever we perform set operations, both the input tables must be union compatible. So if the input tables are union compatible, then only set operators can be applied. Okay, what is in the union compatible? In both the tables, same number of fields must be available and their domains also need to be same in the order from left to right if they are compared. Okay, so if the input tables are union compatible, then only set operations can be performed. Okay, let us now discuss the what are the different set operators are supported by relational algebra. Union, intersection, set difference operators are available. Coming to the union operator, um, it takes two input tables which are union compatible, right? So it works on the two input tables and produces one output table that contains all the tuples that occur in either or both of the input relations, and whenever it produces the output, no duplicate tuples will be available. Whereas coming to the intersection operator, it produces the output relation that contains tuples that occur in both the input relations. Whereas coming to the set difference operator, it returns a relation that contains tuples that occur in only one relation and do not present in the second relation. Okay, let us now discuss these operators with suitable examples. Students, here intersection operator is not the basic operator, it comes under the extended operator. Anyhow, since we are explaining about the set operations, so for easy explanation, because this also follows the conditions that are applicable for other set operations, right? That's why I have included intersection operator here in this slide itself. Okay, for explaining the set operations, we have taken two input tables, that is S1 instance and S2 instance of the sailors. And you can notice both the tables are taking the same number of columns and their the domains are also same. Okay, and when union operator is applied, you can notice union operator that takes tuples which are present in either in one of the table or in both the tables. Okay, here you can see the tuple which is having 22, 31, 58 SID. This is included in the output table, and also here you can see in the second table already 31 is already included and 58 also included. So 28 and 48 is not included in the output table. So you can notice those also included. So the union operator, whenever they are applied on the input tables, they produces the output table that includes the tuples that are present in both the tables or in any one of the table. Okay, if you apply the intersection operator, it includes the tuples which are present in both the tables. Here, what are the tuples are present in both the tables? The tuples which are having 31 and 58. Okay, these are the two tuples present in both the tables. Those are included in the output table. Coming to the set difference operator, it includes the tuples in the output table which are found only in the first input table and do not present in the second input table. So accordingly, what are the tuples which are present only in the first input table? Here 22 is the only tuple that is present only in the first input table. Okay, here you see 31 and 58. These are the tuples that are present in the second input table. So these cannot be included in the output table. So this is the only tuple that is present only in the first input table. Okay, so that's why that is included in the output. You can see here whenever set operators are applied, the schema of the output table is not altered. Coming to the cross product operator is also known as the Cartesian product, which is used to combine each row in one table with each row in the other table. That's why it is also known as the cross product. Okay, here whenever we do the Cartesian product or cross product, the input tables R and S, they may contain one or more fields having the same name. So whenever they are combined, naming conflict may occur. Okay, so in order to avoid the naming conflict, the fields which are having the same name can be unnamed and they can be solely referred by its position. So in order to emphasize that the fields are having the naming conflict, the fields which are having the naming conflict can be represented within parentheses. Okay, so let us discuss the cross product with examples. Here, S1 instance of the sailors and R1 instance of the reserves are taken as input tables, and on this cross product is applied. Okay, so what is the operation of cross product? So every tuple in the first table will be combined with every tuple in the second input table, right? So let us take the first tuple in the first input table and combine every tuple in the second input table. Okay, so here you can see first tuple is taken and it is combined with the every tuple in the second table. Accordingly, let us take the second tuple in the first input table and combine with the every tuple in the second table. Okay, so let us take the third tuple in the first input table and combine it with every tuple in the second input table. Okay, like this cross product operator, it combines every tuple in the first input table with the every tuple in the second input table. And you can notice the output tuple it contains in this SID field. Since SID field is present in both the input tables, when they are combined in the output, so two fields are having the same name. So it leads to naming conflict. So in order to emphasize it, these fields are represented within parentheses. That is, these fields will not be identified using its name and these will be identified by its position only. Students, in this video we learnt about the basic operators in relational algebra. If you find this video useful to you, kindly subscribe this channel. Thanks for watching.